All right, let's dive right in. Today, we're going to learn the secret language of computers. Well, okay, one of the most popular ones anyway, Python. We're going to cover the absolute basics, the fundamentals that take you from writing your very first line of code all the way to building a simple, working program. Let's get started.
I'm serious. Have you ever just wanted to give a computer a list of instructions and have it follow them, like perfectly, every single time? Well, that's all programming really is. It's just about learning the right words to tell the machine exactly what you want it to do. And in Python, that first word is pretty much always the same.
And there it is, print hello world. It's a tradition. It's kind of like a rite of passage for every programmer out there. The print function is just your way of telling Python, hey, whatever I put inside these parentheses, I want you to display it on the screen. Pretty simple, right? And just like that, you've written your first line of code.
Okay, so now that we can talk to the computer, let's figure out how to make it remember things. This is where we get into the real building blocks of any program you'll ever write, data and variables.
Honestly, this is the best way to think about it. When you create a variable, you're basically taking a piece of information, putting it inside a conceptual box, and then slapping a label on that box so you can find it and use it again later.
So how do we actually do that? Well, looking at this example, interest rate equals 0.5. It's really important to know that the equal sign here isn't asking if they're equal. Not at all. It's an instruction. It's called the assignment operator. It tells Python, hey, take this number, 0.5, and store it in a box with the label interest rate. From that moment on, whenever we use that name, Python knows we're talking about the value 0.5.
Of course, you can't just name these boxes anything you want. There are a few rules. First, they're case sensitive. That means rate with a lowercase r is a totally different variable from rate with a capital R. Just remember to stick to letters, numbers, and underscores, and always start the name with either a letter or an underscore. If you can remember that, you'll save yourself a lot of headaches.
And what kind of information can we put in these boxes? Oh, all sorts of things. Python is not just for numbers. You can work with text, which programmers call strings, different kinds of numbers like integers and decimals or floats, and even whole collections of items like lists and tuples. The really cool part is that Python is usually smart enough to figure out what kind of data it's looking at all by itself.
Now, this is a super important concept you gotta get your head around. Some data types, like lists, are what we call mutable. Think modifiable. You can change them after you've made them. But others, like tuples, are immutable. Once you create them, they are set in stone. You can't change them. And that difference is a bigger deal than it might seem right now.
And here is the proof. This is a perfect example. You can see someone try to change an item inside a tuple, and Python just slammed on the brakes and threw a type error. That's the computer basically yelling, nope, you can't do that, this thing is immutable. This isn't a bug or an error in your code, it's a feature designed to make sure some of your data stays constant and protected.
Okay, so we know how to store data. Now let's actually do something with it. This is where operators come into play. You can think of them as the verbs, the action words of our programming language. They're the tools that let us perform actions. Let's start with something we all learned in kindergarten, the plus sign. You give it two numbers, like 1 and 2, it does addition, and the result is, of course, 3. No surprises there, right? But watch this. What happens when you use that exact same plus sign, but this time on two pieces of text on two strings? It doesn't try to add them, that wouldn't make sense. Instead, it just joins them together end to end. We call this concatenation. So the string 1 plus the string 2 becomes the string 12. It's the same operator, but a totally different job based on the data you give it.
This really powerful idea actually has a name. It's called operator overloading. It's a key feature in Python that makes the language feel so flexible and intuitive. That little plus sign is smart enough to know whether it should be doing math or just connecting strings, all based on context. Pretty cool, huh?
In addition is really just the tip of the iceberg. Python has this whole toolbox full of operators for math and logic. Besides your standard math stuff, you also have comparison operators, and pay close attention to the double equals sign double equals. That one asks the question, are these two things equal? Which is totally different from the single equal sign we saw earlier, which assigns a value.
So we can store data and we can perform actions on it. Now, let's give our program a brain. Let's teach it how to make decisions.
This right here is the basic recipe for decision-making in Python. You use if to test a condition. If that condition turns out to be true, your code runs a specific block. If it's not true, you can use elif, which is just short for else if, to test another condition.
And finally, you can use else as a catch-all for when none of the other conditions were met. It's like creating different paths for your program to walk down.
Let's actually see this in action. Just imagine we have a variable named x, and inside that box, we've stored the value -5. Now, we're going to feed it into this if, elif, else structure and see what happens.
So here's how the computer thinks its way through this. First, it checks the if. Is x greater than 0? Well, -5 is not greater than 0, so nope, it completely skips that block of code. So it moves on to the elif. Is x equal to 0? Nope again, so it skips that block too. Since it's run out of specific conditions to check, it has no choice but to fall down into that final else block.
And what's the instruction inside the else block? It's the instruction to print that the number is negative. So that is exactly what pops up on the screen. Our program just made a perfectly logical decision, all based on the data we gave it.
Making decisions is incredibly powerful, but what about doing things over and over and over again? You definitely don't want to be writing the same line of code 100 times. That would be a nightmare. That's where loops come in. They are your best friend for automation and repetition.
Python gives you two main tools for the job. A while loop will just keep repeating a block of code over and over as long as a certain condition stays true. A for loop, on the other hand, is for when you have a collection of items and you want to do something to every single item in that collection one by one. And you have control over these loops too. Think of the break statement like an emergency exit. It just stops the loop immediately, right in its tracks, no questions asked. The continue statement is a little different. It doesn't stop the whole loop. It just tells the program to skip the rest of this one cycle and jump straight to the beginning of the next one.
Okay, let's see how all these pieces, our variables, our decisions, our loops, can actually come together. This simple dice rolling game is a perfect example. It's using a while loop to keep the game going, it uses if statements to check if you rolled the winning number, and it uses variables to keep track of what's happening. This is it. This is a real working program, built from the exact fundamentals we just talked about.
So there you have it. You've literally gone from saying hello world to understanding the core grammar of the Python language. You now know how to store information, how to perform actions, and how to make your code think for itself and repeat tasks. The only question left is, now that you know the language, what are you going to build with it?